Now, next topic, that is moment of inertia. Now, suppose here we consider a rigid body rotating about a fixed axis, then it's each and every particle that will execute the circular motion. Okay? And each and every particle is moving on a circular path with linear velocity v equal to r omega, where r, that is the perpendicular distance of that particle from the rotational axis, and omega, that is the angular speed. Which one is constant for each and every particle, means it is constant for the given rotating body. Okay, so here we can write the linear velocity vi, that is ri omega, and for different particles we can write I, that is 1, 2, 3 up to n. Suppose here we consider any ith particle, then for ith particle the kinetic energy of the particle that we can write ki, that is half mi vi square, but v equal to r omega, so we can write half mi ri square omega square, where mi, that is the mass of that particular ith particle, and ri, that is the perpendicular distance of that particle from the rotational axis, or in other words we can say ri, that is the radius of the circular path of ith particle. Now if we take the kinetic energy of each and every constituent particle of the body, and then after if we take the summation of all these, we will get the total kinetic energy of the body. So we can write the total kinetic energy of the body, that is sigma I equal to 1 to n ki, that is half sigma I equal to 1 to n mi ri square omega square. Here n, that is the number of constituent particles of the body. Here omega, that is the constant for the given rotational motion. So we can write here k, that is equal to half omega square into sigma I equal to 1 to n mi ri square. Now this particular bracketed term, that is known as moment of inertia of the body with respect to that given rotational axis, with respect to that given rotational axis. So here we can give the definition of moment of inertia from this equation like this. Moment of inertia, that is the summation of the product of masses of the constituent particle of the body and their square of respective distances from the rotational axis is called the moment of inertia of that body with respect to that rotational axis. Now here we write the equation k kinetic energy, that is half I omega square. If we compare it with the equation of kinetic energy in the translational motion k, that is half mv square. So when we compare these two equations, then we can understand this thing. The role of mass in the translational motion and role of moment of inertia in the rotational motion, both are same one. So what is the role of mass in translational motion? So in translational motion, mass represents the inertia of the body. Similarly, the moment of inertia represents inertia of the body in rotational motion. So when we write I, that is equal to mr square for point-like object, then we can write its unit, that is kilogram into meter square, and the dimensional formula, that is m1 l2 t0. And here moment of inertia plays a similar role as mass does in linear motion. Okay, clear to all of you?